Section 9.1, Polynomial and Rational Inequalities. Well guys, everyone knows what is inequality. Inequality is something like this. X greater, for example, than 4, right? Or can be something like this. X plus 1 greater than 5. And then to solve inequality is to give the interval of x's which are satisfying this inequality. For example, I'm going to subtract 1 from both sides and get x greater than 4. Usually we give our final answer in interval notation. What is interval notation? I'm going to graph 4 over here. My x's or possible solutions are greater than 4. If I do have greater or equal sign, I'm going to include 4. If I just have greater, I'm going to not include 4. Interval notation is going to be from 4 to positive infinity. And I'm going to write down my answer like this. X belongs to interval from 4 to positive infinity. So any number from here is going to make this inequality a true statement. Okay, how do we usually solve inequalities? There are a couple of different ways to solve inequalities. And way number 1 is use the graph of the function to solve inequalities. So let me erase this. So way number 1, using the graph. Graph of what? Imagine that somebody gives us inequality, x squared minus 4 is greater than 0. What we can do, we recognize that x squared minus 4 is just a parabola. We can write down that x squared minus 4 is making up function y, x squared minus 4. We can graph this function, and that's a normal traditional parabola shifted 4 units down, 1, 2, 3, 4, somewhere here. I'm going to look like this, right? Over here I'm going to have 2, and over here I'm going to get negative 2. Y equals 0 when x equals plus minus 2, right? That's a normal parabola. Well, because this expression, x squared minus 4 is equal to y, so if y is greater than 0, then my inequality is going to be true. Where y is greater than 0? Y is greater than 0 here and here, right? Generally, y is greater than 0 everywhere over here. Positive direction of y-axis. So we are going to have two intervals which are going to make up solution. Interval number 1 is going to be from negative infinity to negative 2. Interval number 2 is going to be from 2 to positive infinity. The little u between two intervals is a unity sign, means that I want to consider these two intervals together. It's like gluing them together. Okay, so I'm going to kind of shade the second interval, and that's going to be solution of this inequality. So all x's which belong to these two intervals are going to make this inequality true. Second way to solve the very same inequality is to use test points, and this is going to be algebraic way to solve inequality. Sometimes algebraic way is a little bit better than graphical way, because sometimes you just don't know how to graph the function, or graphing is too complicated. So way number 2, algebraically. So I'm going to use the very same inequality, x squared minus 4 greater than 0. How I'm going to solve it algebraically? Well, first I'm going to factor it. Remember, in previous section I was teaching you how to factor this. This is a square minus a square of another number, which is actually 2 squared, right? So I can factor it into x minus 2, x plus 2 greater than 0. What I'm going to do next, I'm going to find possible 0 here and possible 0 here. So I'm going to make this parenthesis equals to 0 and this parenthesis equals to 0. Which is going to give me two possible solutions, x equals 2 for this one and x equals negative 2 for this one, for the second one. I'm going to graph a number line and put over here negative 2 and over here positive 2. These two numbers are splitting all my x-axis into 3 subintervals. From negative infinity to negative 2, from negative 2 to 2, and from 2 to positive infinity. I'm going to use one test point on each interval to check if it's making my inequality true or false. True inequality is going to be when this expression is greater than 0. So I'm going to plug in 1 point from here, 1 point from here, and 1 point from here. So I'm going to start plugging in the point from over here. I'm going to use point x equals negative 3. X equals negative 3. If I plug it in over here, I'm going to get minus 3 minus 2 by minus 3 plus 2. Well, this is minus 5. The first parenthesis, second parenthesis, minus 1, and I'm going to get positive number, right? Plus 5, greater than 0. Greater than 0 is good for us, so I'm going to label this interval as true. Now I'm going to plug in a point which is between minus 2 and 2, and which is going to be 0. 0 is easiest point to use, right? 0 here and 0 here are going to give me a product of negative 2 and 2, which is going to be negative 4, less than 0. Less than 0 is not good for us. We are searching for greater than 0, so I'm going to put F, false. And the point over here is going to be, well, can be any point. I'm going to use point x equals 5. You don't have to use x equals 5. It's just supposed to be any point greater than 2. So x equals 5 is going to give me 5 minus 2, which is 3, and 5 plus 2, which is 7. So it's going to be 21. Well, I don't have space over here, but I'm going to just write down that 21 is greater than 0, which is going to be good for us, and inequality is true. Again, writing down my answer in interval notation, I'm going to include only true intervals, which are going to be from negative infinity to minus 2, and from 2 to positive infinity. Well, which is the very same solution we had before, just a different way to do it. Sometimes this way is faster, sometimes other way is faster. Okay? So, let me consider several examples of actual inequalities solved. And I'm going to erase all this stuff because it's not enough space for me. So I'm going to move to my example number 2, which is probably example number 1, and my inequality is going to look like x to the power of 4 is greater than x. How do we solve this inequality? Step number 1, because we can compare everything to 0 very easy, like we do know that 1.5 is greater than 0 and minus square root of 2 is less than 0. It's best to convert this inequality in inequality compared to 0. For example, I'm going to move this x to the left side of my inequality. So that's x to the power of 4 minus x greater than 0. Again, it's much easier to compare anything to 0 than actually, you know, square root of 2 to 15 over 16, for example, or 16 over 15. You really don't know what is going to be greater. But if you compare everything to 0, it's easy. It has minus, it's less than 0, has plus, it's greater than 0. Okay, what is next step? Next step is to factor this expression. So I'm going to factor it. I'm going to take x out of both terms, and my first term is going to have just cube left, and my second term is going to have just 1. Next step, I'm going to factor this. One of the formulas of previous section, x cubed minus a cubed, is going to give me what? The difference of cube, it's 1, x minus 1, and here is going to be x squared, right? Plus x multiplied by 1 and plus 1, the square of 1. Well, I'll need to solve this greater than 0. As in previous case, I'm going to try to do it algebraically, and algebraically I'm going to find zeros of all factors. 0 of this factor is just x equals 0. 0 of this factor is x equals 1. And there is going to be no 0 of this factor, no rational roots. In my notes I put actually y, it has no rational roots. Here I'm just going to say no rational, or no real roots actually, not rational, real roots. So there are just two zeros, I'm going to graph them, 0 here and 0 here. So it's a 0 here and 1 over here, and just going to give me 3 intervals again, which are going to give me like 3 test points, which I'm going to check. So according to my notes, I'm checking points minus 1, 1/2, and 2. So let's check minus 1, minus 1. Since over here, I'm going to plug in over here minus 1. Well, I don't have any space here. So guys, I'm going to move up to plug in the points. So I'm going to put it over here. X equals minus 1, and minus 1 here is just minus 1. Minus 1 here is minus 2. And minus 1 here, it's a 1. Minus 1 plus 1, it's 1 again. So I have two negative numbers multiplied, which is going to be a positive number. So over here it's going to be positive. We do need positive actually, so I'm going to say that it's true over here. From 0 to 1, x equals 1/2. Not necessarily 1/2, but I'm just choosing 1/2. So 1 over 2 for x. Here 1/2 minus 1 is negative 1/2. And over here 1/2 is 1/4, 1/2 here and is going to give me something positive, positive and plus 1, positive number. So I'm going to have positive number, negative number, and over here something positive, which is going to give me a negative number in total, right? Negative number is 4th for me. And my last point is going to be point, let me see what I checked in my notes, it's 2. So I'm going to plug in 2 here. So 4 big expression over here, 2 here, 2 here is going to give me 4 plus 2 plus 1, positive number. Here 2 is positive and 2 minus 1 is also positive, so it's greater than 0. And I'm going to put also true here. So my solution is going to look like this, from negative infinity to negative 1, and from 1 from negative infinity to 0, sorry, this is 0 endpoint, and from 1 to positive infinity. So I solved this inequality, and 2 intervals are solving it. Okay, this was polynomial inequality. Polynomial means that it has powers of x, some coefficients, and can have several different terms, but there is no fractions in it. Now I'm going to move to fractional inequalities, or also called rational inequalities. Let me erase this stuff. So example number 3, rational inequalities. Usually rational inequalities are going to have fraction. For example, rational inequality x minus 1 divided over x plus 3 is greater than 4. Okay, how do we solve this rational inequality? Step number 1, compare everything to 0. Again, everything is easy to compare to 0 and not that easy to compare to anything else. So I'm going to move this 4 to the left side of my inequality. It's x minus 1 over x plus 3 minus 4 greater than 0. Now, step number 2, simplify the result. So I'm going to multiply by x minus 3 this 4. So it's x minus 1 minus 4x plus 3 divided over x plus 3 greater than 0. I'm going to simplify it further. So that's x minus 4x going to give me minus 3x. Minus 1 is going to give me minus 12, 13, I think. And denominator is x plus 3 greater than 0. Okay, so what are solutions? Again, I'm going to use the intervals method, so I'll need to find zeros of all factors here. And we don't have any factors, actually we have like numerator and denominator, does not matter. So I'm going to search for 0 of this, and I'm going to search for 0 of this. One of them is going to give me x equals negative 13 over 3. Imagine that I move this over this side. And one is going to give me x equals negative 3. Now, what is greater out of these two? Remember, I was telling you that everything is easy to compare to 0, but it's not easy when you compare two numbers. Well, what is negative 13 over 3? If you divide negative 12 over 3, you are going to get negative 4. So negative 13 over 3 is going to be even smaller than negative 4. So my number is going to be negative 13 over 3 first, and then negative 3 over here. Well, now I'm just going to check some checkpoints, and my checkpoints are going to be minus 5, minus 4, and 0. Well, I'm going to start with x equals 0. Check what I'm going to have. X equals 0, points over here in this interval, 0. 0 here is going to give me negative 13, 0 here is 3, divided negative 13 by 3 is negative numbers, so it does not work for us, it's false. Okay, now I'm checking x equals negative 4, plug it in here, at minus 12 minus 13, no, minus 12 minus 13, sorry, 3 by 4, 12, and 2 minuses, so it's 12 minus 13, and minus 4 plus 3. Well, 12 minus 13 is negative 1, minus 4 plus 3 is negative 1, 2, so it's 1 greater than 0, so it's true for us because we need greater than 0. And the last point, which sits over here, is going to be negative 5. X equals negative 5 is going to be, well, just plug it in over here. Negative 5 by negative 3 is going to give me 15 minus 13 and minus 5 plus 3. So here 2 and here negative 2 less than 0, which is equal to 1, right? sorry, doesn't fit over here, equals to 1, equals to -1, less than 0, and I'm going to have false over here. So here, my actual answer is going to be interval from -13/3 to -3. Okay, so that's going to be my final answer. So I'm going to give a couple of problems to you, solve yourself, and then I'm going to solve them myself too. Okay, let me write down the problems. And I'm going to count to 5 and do the solution myself. So problem number 1 is 3x cubed is less or equal than -15x squared. Problem number 2 is 5x minus 3 greater than 3x plus 1. So 2 problems. Let's see if we kind of can solve them. 1, 2, 3, 4, 5. Okay, let's start solving first inequality. A. 3x cubed less or equal than -15x squared. What I'm going to do, I'm going to compare everything to 0. So it's 3x cubed plus 15x squared less or equal than 0. I'm going to take outside of parentheses for this term 3x squared, and left over is going to be x. From this term also 3x squared, 3 is a part of 15, right? Which is going to have left over of 5. X squared is going to go the whole thing. Now I'm going to find zeros. 0 here is just 0, and 0 here is going to be x equals -5. And I'm going to graph my number line and try to figure out which intervals we are going to include in our solution. So we have 3 intervals from -infinity to -5, from -5 to 0, and from 0 to infinity. I'm going to choose checkpoints x equals -6 here, and here -4. And I think over here I'm going to choose just 1, okay? So points are -6, -4, and 1. So -6 plugged in over here, you see that this term actually is always positive, just because it's a square, right? No matter what you plug in, it's always going to give you either 0 or positive number. Because I'm not plugging anything what can it turn to 0. This term is always going to be positive. So I'm going to have a positive number, and -6 here is going to give me -6 plus 5, a negative number, -1 actually. So on my first interval is negative. I'm going to label it as minus here, negative. My second interval from -5 to 0, point -4. Again, this term is always positive, not term factor. This is going to be -4 plus 5, which is going to give me 1. So positive by 1 is positive. So I'm going to put a little plus over here. And 1 over here, still positive number here. And 1 plus 5 is 6, also positive. So I have minus, plus, plus. Now, what I'll need actually, minuses or pluses, let's look at the sign of inequality. Not always inequality is going to be greater than 0. This one is less than 0, so we'll need minuses. It also allows us to use 0. 0 is where inequality is kind of actual expression over here is equal to 0, so it's allowing us to have 0. So what I'm going to have, my interval is going to be from -infinity to -5, and -5 is going to be included because of this equal sign. Okay, so my first inequality is solved. Let's move to the second inequality. Wow, because I'm going to raise actually all solution of the first inequality. And the first inequality itself from the board, so it's not going to confuse us. Maybe it was not a good idea to put 2 of them at the same time on the board. Okay, for the second inequality, I'm going to compare everything to 0. I'm going to move actually this expression to the left side and bring it to common denominator. Common denominator is going to be x minus 3, x plus 1, not very interesting, x minus 3, and x plus 1. So here I multiply by x plus 1, so it's 5x plus 1. And here I multiplied by x minus 3. I'm going to modify this expression and then put not equal sign. Normally, each time you rewrite inequality, but I have much space here. So I have 5x plus 5 minus 3x minus 3 by minus 3 plus 9, and divided over x minus 3 and x plus 1. I'm going to simplify my numerator, which is going to be 5x minus 3x, 2x, and plus 5 and plus 9, which is going to give me 14. and x minus 3 and x plus 1. Again, I'm going to look for all zeros of all factors here, numerator and denominator included. So I have 2x plus 14 equals to 0, which is going to give me x equals negative 7, right? 14 is going to be on this side, minus 14 divided over 2, negative 7. Denominator easy to find, x equals 3 and x equals negative 1. Now I'm going to graph all three numbers, starting with negative 7, and then negative 1, and then 3, and check 4 intervals I have. Well, for this interval, I'm going to check number minus 8. So let's imagine that we plug in minus 8 into my inequality. Minus 8 here is going to give me minus 16, plus 14 is minus 2. Minus 8 here is going to give me a negative number, and over here is going to be negative number 2. So I have negative, negative, and negative. 3 negatives is going to give me minus here. Okay, now I'm going to plug in something between negative 7 and negative 1. I think I'm going to plug in negative 2. Let's see what is going to happen in numerator. Negative 2 here is going to give me negative 4 plus 14 positive. Negative 2 here is going to give me negative minus 5, and negative 2 here is going to still give me negative. So I have positive and 2 negatives. Plus, 2 minuses are going to give me plus, right? Now I'm going to plug in over here, well, you can guess 0 because it sits between negative 1 and 3. So 0 here is going to give me 14, 0, 3 minus 3, and plus 1. Plus, plus, minus. Well, again, negative. And the last one, I'm going to plug in probably 4. So let's see what 4 is going to give me. 2 multiplied by 4 is 8, plus 14, positive number, 22. 8 minus 3 is 5, and 8 plus 1 is 9. So all positive numbers, so I'm going to have plus. What I'll need for this inequality? I'll need positive numbers. So my positive numbers are from negative 7 to negative 1, and from 3 to positive infinity. That's my final answer. Okay, I'm going to box it. And I think that's all for this section. Practice a bit more with inequalities, doing the homework, and ask me any questions if you have. Thank you.